Okay, probably my favorite area in algebra, exponential and logarithmic functions, because there's lots of stuff that can be modeled. Zombies are everywhere. They're multiplying exponentially, right? And you're going to see all a logarithm is another way of writing an exponential. So we'll get into how do we even evaluate exponential functions, how do we graph them. You can kind of already think of something that rises exponentially. It's going to rise up very quickly. Diseases. Let one kid get sick in daycare, see what happens. Evaluate with base E. E is like pi, meaning it's a number. So you'll see that 2.7128. It's on your calculator. You'll find it on there. And then the don't get yourself in trouble with compound interest. You know what I'm talking about, them credit cards, right? All right, so that's definitely something good to know. And then we'll look at, I said, remember, a logarithm is an exponent. So we'll look how to switch from back and forth, how to evaluate logarithms, lots of different properties, find the domain, because you're going to see that a logarithm kind of hugs up next to that y-axis but never touches it, which means the argument within the logarithm can never be negative. And so that's where we get into the domains, and then look at the difference between a base 10 logarithm versus a natural, the base E logarithm. Lots of different properties of how to use the product rule, quotient rule, power rule. One thing I like about logarithms, they have the same properties as exponentials because they're inverses of each other. Remember, you learned about inverses and how we can either expand out a logarithm or condense it. What do we do? How do we calculate if we don't have that particular base on our calculator? So the same change of base. Also look at like bases to solve exponential equations. How we can use logarithms. And definitely the best part is going to be able to see this stuff applied in real life applications. And this is the end part where finally we can model exponential growth, something that grows very quickly. You're going to see exponentials also can be something that's decaying. And then finally use logistic growth models. Again, I go back to the zombie one where zombies are multiplying very quickly. Okay, so run for your lives, right? And then they kind of even out towards the end. So I hope you enjoyed this section.